Okay, we're now recording. All right, no classes at all tomorrow. Tomorrow is a flex day for all of CSM, so no class for me. And if you have any other CSM class, no class tomorrow at all. It's a flex day. We meet again on Friday. I should finish 4.8 today fairly rapidly. Then I had some requests to go back and do some other problems, so I'll be doing that. Okay. Quiz on Friday, it'll be an applied max-min problem. And just like last week, I'm going to give you a huge chunk of time, maybe not as much as last week, but maybe half an hour-ish to do the one applied max-min problem. Okay, that'll be sort of like what we did before. Okay, now that being the case, as I said, I will go ahead and do 4.9, 5.1, and so on. Okay, so I should finish this today. In fact, I'm just going to go ahead and mark it off. Okay, so coverage for next Friday's test is chapter 4, except there's no 4.6. 4.9 really belongs in chapter 5, in my opinion. And when we get there, I'll show you why. Okay, so even though I'm going to lecture on 4.9, 5.1, maybe next week, that will not be on the test. And as I usually like to do, I'll reserve Thursday the 29th for questions and answers. Okay, and then the test will be here. Okay, so again, you know, I'm not against the flex day. I mean, I like it too, and I'm sure you do also. But if we did not have the flex day, or let's say the flex day was over here, we would have had the test on Friday, because I would have finished everything by today, right? And then tomorrow, questions and answers and test Friday. But since we don't have that day, and I want to leave you a day with questions and answers, so that's why I'm pushing it back over to here. Again, an option I could have had, but I'm not really going to do it, and I'm sure a lot of you don't really like that, is to give you the question and answer session on Friday and give you the test on Monday. But, you know, I don't really feel like giving you the test on Monday. And besides, that's more pressure for me to get it back to. I won't have a chance to get it back to you the next day, perhaps. But usually if I have a test on a weekend, then you feel relieved because, you know, you got the weekend, it's over, and then I have the whole weekend to grade it. So, yeah. Okay, so that's where we're headed. All right, so I'll give you a lot of time, quote unquote, maybe half an hour to do the applied max-min word problem on Friday. Okay, so that's as much as I'll say about that. Okay, and again for the test, I realized to do a full-fledged curve sketch like the one I gave you last week, f of x equals x e to the x, that does take a long time. I realize that. And even the full-fledged word problem might take a long time. So I have to keep that in mind when I construct the test, but I don't mind giving you something like that for a quiz where you get to help each other out and so on. Okay, so again, last week's quiz was challenging, and this week's quiz might also be challenging. It's an applied max-min problem, but it shouldn't be that unusual. It should be something sort of like the word problems that we saw already. Okay. All right, and let's see, any questions about that? I don't see anything in the chat right now, so we'll go ahead and start. Okay, so I'm going to finish up a little bit more of 4.8. I'm actually going to go back and do one of the ones from yesterday because I kind of rushed through it. And then I'll do another one. Then I'll be done with 4.8. Then I had some requests for some previous problems and limits. I think it was 4.4. All right, so here we go. So 4.8. 4.8, what do you want to put on your cheat sheet? Page 346, either put this, x of n plus 1 equals x of n minus f of xn over f prime of xn. So box 2, page 346. Okay. Or you can have my version, which is equivalent. X new equals x old. How do I get the new value? Take the old value minus function over derivative, or f over f prime. Plug in that x value. Okay, and when you're doing a shortcut, you hit the answer button, A and S. Okay, and my informal survey from yesterday, most of you have a calculator that has the answer button. Okay, a few of you said you didn't. If you didn't, you can still do the problem. It might take you a little bit longer to do it, but you know, again, I'll construct the test if I ask you a question on that so that everybody can do it, whether you have the answer button or not. Okay. All right, so here we go. Let me go back and do 16 again because I kind of rushed through that. So find a solution of 3 sine x equals x to 6 digits. Okay, so remember, in order to do that, you have to have 0 on one side of the equal sign. So just subtract the x over. 3 sine x minus x equals 0. Okay, so this is my function, 3 sine x minus x. The derivative is 3 cosine x minus 1. So function derivative. Okay, now you have to guess a first number. In reality, you could guess anything, but okay, as I said, you know you're not going to plug in anything bigger than 3 because sine x is between -1 and 1. So if sine x is stuck between -1 and 1, you know you can't have 4. Okay. It's not going to be 3 because that forces this to be 1. So I decided to try 2, and it asks for the positive root. Okay. So I start off with 2, and then throwing into the formula would be answer minus 3 sine answer minus answer. That's plugging into here. Divided by 3 cosine answer minus 1. Okay, so I'll demonstrate it again. Start off with your first guess. So I typed in 2. So 2. Now I literally typed this, and I better make sure I'm in radian mode. Okay, yeah, I just taught my other class in trig, and they were in degrees, so I have to switch back to radians now. Okay, so now I'm in radians. Okay, so your first guess, you type it in. So now inside the memory location called answer is 2. So now I'm going to type answer minus, trying to type all this in, parentheses 3 sine parentheses answer minus second function answer. Okay. Function on top divided by parentheses 3 cosine answer, 3 cosine parentheses answer minus 1 close parentheses. So that's exactly what I had here. See if I can show you both on the same screen. Answer minus 3 sine answer minus answer parentheses. When you do this, you should always put extra parentheses around the whole top and the whole bottom. Otherwise, you might have issues with order of operations. 3 cosine parentheses answer minus 1, 2.32. And you should write these separate iterations for me. Now, if you don't have an answer button, you have to type this all in again. So it's you're a little bit handicapped, but you just lose maybe a minute or two. For everybody else, I'll just keep pressing enter. 2.279, 2.2788, whatever. 2.778863 rounded off. And these two match. So if they match, you've got the solution. So they said 6 digits, 2.2788863, and there we go. All right, so when you do this process, if you ever get 2 that match, you're done. Okay, again, the reason why. Okay, if x sub n plus 1 equals x sub n, that means I have to be subtracting 0 if they're equal. And when is a fraction 0? When the top is 0, and that's what we're looking for. We're looking for f of xn equals 0. Okay. All right, so that was that one again. Show you that, but it should already be in your in the previous video. Okay, then that is for that one. The only other one I was going to show you was 14. Then I'm basically done with the section. Then I think I would have shown you all the evens. All right, 13, 14. Explain how we know the given equation must have a root in a given interval. Use Newton's method to approximate the root correct to 6 decimal places. Okay, so 14, negative 2x to the 5th plus blah, blah, blah. And the interval is from 3 to 4. Okay, so what do they mean by explain how we know whatever? Okay, so here's problem 14. There must be a solution on the given interval. This is based on something called the intermediate value theorem. Okay, that was back on 2.5. So let me go back and show that to you. So a long time ago, 2.5, intermediate value theorem. Page 122, that's a 122 there. 122. Intermediate value theorem. Suppose f is continuous on a closed interval from a to b. Let n be any number between f of a and f of b, where f of a is not equal to f of b. Then there exists a number c in ab such that f of c equals n. Okay. It's a long time ago, I know. So in particular, this is the idea behind the homework problems. For a continuous function, is this continuous? Yes, it's a polynomial. All polynomials are continuous. It's continuous between 3 and 4. Okay, f of 3 and f of 4 are of opposite signs. One's positive and one's negative. Okay, I plugged in 3. I'll let you do that on your own. It comes out to be positive 21. Plug in 4, comes out to be negative 236. And this should be a C here. One positive, one negative. Okay, so one side is positive, one side is negative, either like this or like this. So somewhere there has to be a 0. So there is a C somewhere between 3 and 4 such that f of c is equal to 0. So that's the intermediate value theorem. So that's what they mean by that first part. Explain how we know the given equation must have a root in the given interval. Okay, so 13 is similar. 13 is easier than 14, and you got the answer in the back of the book. Looks like an easier function. Okay, it's continuous. One of them was positive. F of 3 was positive. F of 4 is negative. So somewhere you get a 0. Okay, so that's asking you to find where that is. Now, they don't give you a first guess. You know it's between 3 and 4. Okay, I know I'm showing you the answer right now. But if you had to guess, they say, pick something, you know it's between 3 and 4. What should I pick? 3.5. So that was my first guess, right? Is it 3.5? Maybe, maybe not, but you know it's between 3 and 4, right? So I picked the one that's right in the middle. You could have picked 3.2 or 3.9, but I figured out, well, we'll pick the one in the middle. All right, so the function is negative 2x to the 5th plus 9x to the 4th minus 7x cubed minus 11x. We need f prime, negative 10x to the 4th plus 36x cubed minus 21x squared minus 11. Okay. All right, so 3.5 is my first guess. So to do this with the answer button, can you first put your first guess, 3.5? Okay, so type in 3.5, it's in memory. So now that's inside the answer memory. And now I use the formula, right? So answer minus, put answer there, 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 and there. It's tedious. Put answer there, there, and there. It's tedious. But for those of you that do have the answer button, you only have to do it once. If you do not have this answer button, sorry, you got to type it every time. Okay, so now I'm going to try to type all this stuff in. Answer minus parentheses, negative 2 answer to the 5th power plus 9 answer to the 4th power minus 7 answer to the 3rd power minus 11 answer divided by parentheses, all this stuff, negative 10 answer to the fourth plus 36 answer cubed minus 21 answer squared minus 11. Okay, I'm not sure if I can show you both on the same screen. I'll try. Yeah, so all of that. Here, answer minus negative 2 answer to the fifth, sorry for the glare, plus 9 answer to the fourth, minus 7 answer cubed, minus 11 answer. Notice a parentheses around the entire numerator. So paren there and paren there. Divided by paren, negative 10 answer to the fourth, plus 36 answer cubed, minus 21 answer squared, that's answer there, minus 11. Okay, 3.329. And when you do this for me on a test, show me, you don't have to show me all the digits until the last one, but I want to see what each iteration gives you. So 3.329, blah, 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 blah. Okay. Now, stored in memory is this thing, and the last operation is this, which means I don't have to type it all over again. I just press enter. Here we go, 3.32787, 3.2745, and so on. So we're converging to the right number, 3.2744, whatever. Next one. So practically the same thing. Okay. So they want 6 digits, 3.274473. Okay. And just out of curiosity, yeah. By now my calculator has what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits to the right decimal point. These two match exactly, so you know you pretty much got it. You say so whenever you get successive iterations to be equal, then you're done. So there we go, 3.274473 to 6 decimal places. Okay, and let me raise it up so you can see it. Okay, so I'm done with that, and I'm actually finished with a section, and I'm actually finished with the entire chapter. Okay, but I am going to go back and do some more 4.4 stuff. Okay, so I got some questions about L'Hopital's rule from 4.4. So let me go back and do some of those. Okay. And by the way, for next Thursday's review, if you ask me some questions, especially involving curve sketching, sorry, I may not want to do a problem in its entirety because it just might take too long. I mean, I could end up taking a whole class period just for one problem or 2 problems. So I'll have to kind of pick and choose. So you may not see me do the entire thing. Again, usually on review days, I'm going for quantity more than quality. I want to make sure I get as many problems done. You can always go back and look at the video and, you know, pause, fast forward, rewind as much as you need. Okay, so 4.4, L'Hopital's rule. I got a question about 45. So limit x approaches 0, sine of 5x cosecant 3x. 47, limit x approaches infinity, x cubed, e to negative x squared. Remember, the idea behind L'Hopital's rule is to get it to be a fraction. Okay, and I think I already did 55, but I'll rehash that one more time in addition. So let me show you those. So going way back to 4.4, limit x approaches 0, sine 5x cosecant 3x. Okay, now, you know to do L'Hopital's rule, you got to have a fraction. Can you see an easy way to get a fraction? Well, we don't like cosecant. Right? So what's the reciprocal of cosecant? Sine. So sine 5x over sine 3x. And there we go. And now I can do L'Hopital's rule. That's 0 over 0, right? Put a 0 there, sine of 0, 0. Put a 0 there, sine of 0 over 0. Okay. Now, you might recall when we did the last chapter, you actually could do this without L'Hopital's rule. You might recall you needed to have this divided by 5x, You need this to be divided by 3x, and then just multiply by the right thing to get it to balance. Okay, but now that we're armed with L'Hopital's rule, it's easy to just do that. So take the derivative of the top. That's LHR, which stands for L'Hopital's rule. Okay, I won't take off points if you don't put LHR on the test. I don't know what you did, but if you want to, you may. Okay, so what's the derivative of the top? Cosine 5x times 5. Derivative of the bottom is cosine 3x times 3. Okay, and now you can directly plug in. So plug in 0 here, plug in 0 here. Cosine of 0 is 1. So I have 5 times 1 divided by 3 times 1, 5/3. Okay, so the answer is just 5/3. All right, then 47. Limit x opposed to infinity of x cubed e to negative x squared. Okay, can you see a very easy way to make this into a fraction? The negative x squared, right? Bring it into the denominator. Then you have x cubed over e to the x squared, right? All right, that's infinity over infinity. If I plug in a big number, x cubed is big, e to the x squared big. So infinity over infinity. So L'Hopital's rule, take the derivative of the top, 3x squared. Derivative of the bottom, derivative of e to the x squared is itself, e to the x squared. And then by the chain root times the derivative of x squared, which is 2x. And I can cancel one of these x's with one of these x's. So I'll have 3x over 2 e to the x squared. That's still infinity over infinity. So remember, you might have to do L'Hopital's rule more than once. Then we had one problem we had to do it a total of 4 times, something like that. Just keep going until you finally do not get either 0 over 0 or infinity over infinity. Okay, if I plug in a big number, 3 times big is big, 2 e to the big squared is big. So L'Hopital's rule again. Derivative of the top is 3. And I know I don't have to go any farther, right? Because the top is 3. So it's not going to be 0 over 0. It's not going to be infinity over infinity. I know I can stop after the next step. Derivative of 2 e to the x squared is 2 e to the x squared times the derivative of x squared, which is 2x. All right, so that gives me limit x opposed to infinity of 3 over 4x e to the x squared. And now that does it. The top is 3. The bottom is big, right? Plug in a big number, plug in a billion. That's big. E to the billion squared is big. 3 over super big number, 0. Okay, then I was going to go back and show you 55, although I think I did it before, but I'll show it to you again. But to emphasize that limit x opposed to infinity of x minus ln x, that's sort of like infinity minus infinity, big number minus big number. So what happens if you have big minus big? We don't know. It kind of depends on which is bigger, right? It might go to infinity, it might go to negative infinity, it might go to a number. Can't tell. Now, big plus big is big, right? Big number plus big number is big number, but big number minus big number, can't tell. Right, so here's one of those where, okay, how do I force a fraction? There's nothing there. So I just put x over x. That's how I'm forcing it. And then I split it into 2. Okay, the limit of a product is a product of limits. So I write it as the limit is x opposed to infinity of x times the limit is x opposed to infinity of x minus ln x over x. This is going to be easy. This one I'm going to split into 2. Right? So do limit x opposed to infinity of x over x, 1. And then minus limit is x opposed to infinity of ln x over x. So I'm going to leave this alone. This one, break it up into limit x opposed to infinity of x over x, 1, and then minus limit x opposed to infinity of ln x over x. Okay, so I have this, which is easy. It's a big number. I have this, which is easy. That's 1. And now I just have to figure this out. Limit x opposed to infinity of ln x over x. So again, sometimes you have to force there to be a fraction. L'Hopital's rule works on a fraction. If there isn't a fraction, you make it a fraction. Okay, so this is infinity over infinity. Leave that alone. That's 1. So L'Hopital's rule, limit x opposed to infinity. What's the derivative of the top? 1 over x. Derivative at the bottom is 1. Okay. And now you can see, if you divide by 1, you can just forget about it, right? So now what happens when x gets big? 1 over x approaches 0. So I've limited x approaches infinity of x. That's 1 minus nothing. Okay, so this is 1. This is a big number. When x gets big, it's redundant. When x gets big, so big number times 1, big number. So the limit is infinity. So there we go. Okay, so folks, I am now officially done with the chapter. Okay, so I'm completely done with this. Again, in my opinion, it's a little bit bad that we have a flex day tomorrow, because otherwise, again, if we didn't have the flex day, I'm finished with this. Then I would have said questions and answers tomorrow, test on Friday. But because we have the flex day, I'm switching over. So that being the case, I'm actually going to get started now. What time is it? I have 20 minutes left or so. I'll get started with 4.9. It will not be on next Friday's test. And however far I get now, 4.9, 5.1, maybe 5.2, I don't know. Okay, we'll see. So take notes, but don't study this material very much until after next Friday, I would say. Okay. By the way, I'm aiming right now for the last exam to be Thursday, the 20th. That way we can do a mini review session on the 21st. Now, I'm not promising that I can get you back the test by the very next day, but I'll have it by that weekend. Okay, our final exam on the schedule is Monday, May 24th. I can't change the date or the time. And please notice it's 8:10 to 10:40. So we start at 8:10 that day, not our normal time of 9:10, but 8:10. So you have 2.5 hours just for that one day. We start at 8:10 in the morning from the final exam schedule. Okay, I don't think it's that bad. I mean, you only have to do it once. Okay, I don't know. It's kind of like if you had to gear up to take a plane flight. Some of you have taken plane flight real early in the morning. I don't know. I've taken plane flights that were like 6 in the morning, but you know you got to do it. So you got to do it. You got to do it. You get up early and all that stuff. So just for that one day, if you're not used to waking up at, early, just for that one day, do that. Now, if you started the final exam at 9:10, our usual time, I'll let you, but I'm stopping at 10:40. I can't go past because I have to give another final exam after that. So you'll just have less time to do the final exam. All right. So that being the case, I will get started with 4.9. Go ahead and take notes if you wish, but look at it kind of half-heartedly and start focusing on it more once Friday the 30th gets passed, and then we get into over here. Okay. All right. So let me check questions. Anybody? Some people just joined. Got it. All right. So any quick questions about what's happening? Okay. So coverage for the exam is up to now. I've completed all that. But I'm going to get started with 4.9 today and Friday. Again, Friday, I plan to give you hopefully a good half an hour for the one question, just one question. But just like last time, the one question took, almost the entire class period. It's going to be an applied max-min problem. It's somewhat similar to one of the problems that you've already done. Okay. All right, so 4.9, here we go. We're getting there. Again, in my opinion, 4.9 belongs in chapter 5, page 350. Anti-derivatives. So this whole semester, we've done derivative, right? What's the derivative of this? What's the derivative of that? What's the derivative of polynomial, exponential, logarithm, trig, inverse trig, right? Product, quotient, chain rule, derivative. Now we have anti-derivative, which sort of sounds like we're going backwards, and that's exactly what we're doing. We're doing anti-derivatives. Okay, so on page 350, definition, a function capital F is called an antiderivative of little f on an interval I if f prime of x equals f of x, capital F prime of x is little f of x for all x in the interval I. Okay, antiderivative. in some sense, we're going backwards. Okay. All right, so I'll give you the Melvin Hahn version. We have here antiderivatives. Now, some symbolism, and I'll hasten to add, our author, Mr. Stewart, does not use this symbol in 4.9, which I really think he should. Okay, he introduces it later. Okay, so this funny looking S, f of x dx. Okay, first, how do you say it? The integral of f of x dx. Okay, this is sometimes called the integral sign or integral symbol, integral, I-N-T-E-G-R-A-L, integral. Okay, and just a side note, Mr. Stewart has this violin here. Okay, and if you look at a typical violin, he was a violin player. I'm guessing some of you are violin players. Okay, so the violin has that funny looking S. And so he has that, you know, as the integral sign at the cover of the book. So, haha, big joke, whatever, right? All right, so how do you read this? The integral of f of x dx. Now, you won't see that symbol anywhere in this section, but I'm going to use it. It'll show up later. If you look at the homework problems, he doesn't use that symbol. Okay. He just says something like, find the most general antiderivative, blah, 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 blah. Okay, so that symbol's not there, but even though that symbol's not there, I'm going to use it. I really think he should have used it. Not to where he ends up using it in chapter 5 later on. So go ahead and use the symbol that I'm going to have. So again, I'm going to write the symbol. You won't see it anywhere in 4.9, but you'll see it in chapter 5. Okay, so it'll take me a while to just develop this concept, this idea. All right, so the integral of f of x dx, that's how you say it. What does it mean? So the meaning is give a class of antiderivatives of f of x. And say, I still don't know what you mean, and you're probably not going to until we start doing some problems. But this is the official meaning. Okay, and again, don't study it very much until after next Friday's test. Give a class of antiderivatives of x. Okay, now the process that we're doing is sometimes called integration. Okay, so when I do this anti-differentiation, it means integration. Now, of course, you and I know there's an English word, integration, and of course it has meanings. But in mathematics and calculus, integration means anti-differentiation. Okay, but look at how big the word anti-differentiation is, right? There are what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19 letters, if I count it correctly. Anti-differentiation. So we've done differentiation, taking derivatives. Anti-differentiation, going backwards in some sense. Okay, so we've taken derivatives. This whole semester is pretty much derivative, derivative, derivative. Okay, this last few weeks, anti-derivative, anti-differentiation. Okay, that's too big a word, so we would say integration. So if you hear me say integration, yes, it has an English meaning and several English meanings, but when I say integration, in calculus, when you say integration, it's anti-differentiation. This is the integral sign or integral symbol. So we read this as the integral of f of x dx. All right, so how do you do it? Okay, and what does it mean? So 4.9, number 1, integral of 4x plus 7 dx. And yeah, let me go and do the usual, showing you what the questions are. I'm getting 4.9, 1 to 47, odd, 59 to 63. Page 355, whoops, yeah, 355. Okay, find the most general antiderivative of the function. Check your answer by differentiation. So there's that. There's that. We had to go up to 63. So page 356. There's that. There's that. You may notice when we're doing these problems, the problems start off with f prime. Sometimes it starts off with f double prime, and I think even some f triple prime. Okay, and then over here, oh, I don't think we had to do these. Let me check, up to 47, right? Then 15.9 to 63. Okay, so there's everything up to 47, I believe. Yeah. Okay, and 15.9 to 63 involves a velocity and acceleration. And we've seen that before, kind of. Okay. Now, just to show you what's happening, the author says this: find the most general antiderivative function. So look at number 1. It says f of x equals 4x plus 7. I'm going to write it with the integral sign, integral symbol. Sorry, I can't show you both at the same time. But it says f of x equals 4x plus 7. You're going to write it, I'm going to write it like this: integral of 4x plus 7 dx. Now, without showing you how to do it, at least not yet, I'll just give you the answer that's expected. Okay, so the meaning is give a class of antiderivatives of f of x. Okay, so for this one and for a few problems, I'll show you the answer without showing you how I got it. Okay, the answer is 2x squared plus 7x plus c. C is a constant. All of these problems right now should have a plus c. Okay, notice plus c, plus c, plus c, plus c. Okay, c represents a constant. Okay, so for now, go ahead and put this down. Shortly, I'll show you, how did you get that. But first, let's talk about what the answer is. Okay, notice I'm not asking for the derivative of 4x plus 7. The derivative of 4x plus 7 is 4. I'm asking for a class of antiderivatives of f of x. So what's this class stuff? Okay, 2x squared plus 7x plus c is not just one function. It's a whole bunch of functions. Just change the constant c. So when I write this, it's 2x plus 7x, 2x squared plus 7x plus nothing. But it also includes 2x squared plus 7x plus 1, 2x plus 7x plus 2, 2x squared plus 7x plus 3, plus 80, plus 1,000,000, minus 1,000,000, minus pi, minus square root 2 over 2, and so on. I have infinitely many functions. Okay, that's what we mean by a class of antiderivatives. What do all of those functions have in common? Let's pretend I say 2x squared plus 7x minus 1,000,000. What is the derivative of 2x squared plus 7x minus 1,000,000? What's the derivative of 2x squared? 4x. What's the derivative of 7x? 7. And what's the derivative of negative 1,000,000 or any constant? 0. Okay, so get the idea? So we're not going the derivative route, we're going the antiderivative route. So I'm not asking what's the derivative of this. I'm asking what functions, plural, what functions are out there whose derivative ends up being 4x plus 7. Okay. In some sense, it's like on an elevator. We were always going down the derivative route, always going down, but now we're going back up. Okay. So up at this level, what functions are there whose derivative come out to be 4x plus 7? So the answer is 2x squared plus 7x plus c, which happens to be the answer to number 1, okay, without my even showing you how to do it yet. But I will shortly, eventually. Okay, so first thing you may notice is that when I go the derivative route, there's only one answer. Okay, all throughout the semester, I said, here's f of x, the derivative is blah, 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 right? If I say f of x equals ln x, the derivative is 1 over x, correct? If I say f of x is sine x, dy dx is cosine x, only one function. But when I go the other direction, the antiderivative function, it's not just one function, it's a whole bunch of functions. That's what we say a class of functions. So technically, you cannot say, give me the antiderivative, because there are many antiderivatives, but they differ by a constant. Okay, so when I say integral of 4x plus 7 dx, okay, and by the way, you say, what's the function of the dx? Really nothing right now. It does name what the variable is. Okay, here you might say, well, it's obvious. Yeah, but later on, it will not be so obvious. But we're saying the variable is dx. Later on, you're going to see x mixed up with a, b, c, and whatever. So the dx tells you what the variable is. The variable is x. Sure, you might say, well, it's obvious. It's x. Okay, but technically it does belong there. Okay. So technically you should not say, give me the antiderivative. It really should be antiderivatives, plural. That's what we say, a class of antiderivatives. Okay, so this is infinitely many functions. Okay, they all have a 2x squared, they all have a 7x, and then any real number. That's infinitely many functions. The derivative of any of these functions. C can be any real number. What's the derivative of any of these? 4x plus 7. Okay, so that's what's happening. Okay, 9, integral of radical 2 dx. Okay, we're not asking for the derivative of radical 2. Quick timeout. What's the derivative of radical 2? It's a constant, right? It's like 1.4 something. The derivative is 0. But we're not asking for derivative, asking for antiderivative, or more strictly speaking, antiderivatives. It's a constant. Okay, the solution is radical 2x plus c, which includes radical 2x plus nothing, radical 2x plus 1, plus 2, plus a billion, minus pi. The derivative of any of these functions is radical 2, right? Derivative of radical 2x is radical 2. Derivative of any constant is 0. Okay, so again, for right now, all of these need to have a plus c. Okay, there will be times where we don't put the plus c, but I'll tell you when that happens. Okay, maybe just one more of that type. 17. There's a trig one. Integral of 2 sine theta minus secant squared theta d theta. Again, we're not asking for the derivative, asking for antiderivatives, plural, of this. Okay, so integral of 2 sine theta. Here's the solution. Negative 2 cosine theta minus secant squared theta. You really have to say to yourself, what function is there whose derivative is secant squared? So I think back, oh yeah, that's tangent. So minus tangent theta plus c. How can you check any antiderivative? Okay, so you do this antiderivative stuff, right? So, I wonder if I got the answer right. What should I do? Take the derivative of your answer. The derivative of your answer comes out to be the original. You know you did it right. Okay, is it true the derivative of this is 4x plus 7? Yes. Is it true the derivative of my answer is radical 2? Yes. What is the derivative of negative 2 cosine theta minus tangent theta? So what's the derivative of negative 2 cosine theta, right? It would be negative 2 times negative sine theta, which is the same as 2 sine theta, right? What's the derivative of negative tangent? Negative secant squared. And the derivative of any constant is, of course, 0. All right, so first rule for antiderivatives, power rule. So put this on your next cheat sheet, not on the cheat sheet for this upcoming test a week from Friday, but the last test, test number 5. Integral of x to the n. Okay. So this integration and differentiation are opposite operations. If I ask for the derivative, right, you would go n x to n minus 1, right? Subtract 1, multiply. So guess what happens when you go the other direction? When I take the derivative, I would subtract 1, right? So for integration, anti-differentiation, instead of subtracting 1, what do you think it is? Add 1. Exactly, going backwards. And instead of multiplying by the exponent, I will divide by the exponent. Right. So here's the power rule to put on your next cheat sheet, and not on upcoming test, but the last one. So the integral of x to the n is x to the n plus 1 divided by n plus 1 plus c. There is one restriction. N is not allowed to be negative 1. How come n is not allowed to be negative 1? because what happens when n is -1? Divided by 0. So we will see what happens in that situation. Okay, but for now, integral of x to the n plus 1 divided by n plus 1 plus c. So simple example, what's the integral of x dx? That's like x to the 1. So by this power root, I add 1, x squared divided by 2 plus c. That's the power root. Double check, what's the derivative of this? Pretend that's a half. Don't do the quotient root, pretend that's a half. If I differentiate, 2 comes down, knocks out the half, I have x to the 1. There it is. And of course, the derivative of any constant is 0. And one last thing, I will consider the situation of what happens if you have a -1. Okay, so x at a -1 dx, you cannot do the power rule here and say x to the 0 over 0. Instead, we call that x at a -1 is 1 over x. Do you remember what function has a derivative of 1 over x? Natural log. But strictly speaking, it needs to be ln absolute value of x plus c. A long time ago, okay, we said the derivative of ln x is 1 over x, but we said the derivative of ln -x was also 1 over x. Okay, and then I said that means that you could actually have the derivative of ln absolute value of x is 1 over x. And a long time ago, I said, put that in storage, we'll need that later. This is the later. Okay, so technically the integral of 1 over x is not just ln x, it's ln absolute value of x plus c. Okay, so I see we're out of time. So I'll stop here. Again, anything that I do in 4.9 and on is not going to be on next Friday's test, but I will keep going. So no school tomorrow. Friday, I'll continue with some of 4.9. And then most of the time after that, I'll try to give you at least half an hour. You'll have a quiz on an applied maximum problem. Okay. And then next week, I'll keep going up until Wednesday, Thursday, question and answer, and then Friday's the exam. All right. Okay. Any quick questions? Otherwise, we're done for today. Anybody who joined late, put your name in the chat right now. All right. So that'll be it, folks. So have a nice one-day weekend tomorrow, and we'll see you on Friday. Okay. All right. Have a good day, everybody.